Hi everyone, hopefully you're being very good for the sub today. So we'll start off with the warm-up. Identify the domain and range. So domain is going to represent the x values. So all of these values along here, okay? Range is going to represent all the y values. So all the values along here. Okay, so when I look at this, I want to see if I'm going to write this in a way that is discrete or continuous. So right here, I do have two problems, 1 and 2. On the left, you can see we have a lot of dots, right? So remember, D for dots, D for discrete. So this is a discrete, and this over here is continuous. Okay? And so when I'm looking at the domain, what I want to do is put the domain in brackets, okay? So, remember, we want to look at every single one and go down. So I have -2, -1. -1 is twice, but remember, there's no duplications. 1, 2. Okay? So I'm going to write that down in order. So I have a -2, -1, 1, and 2. Go ahead and put the brackets. Make sure they're the fancy ones. Okay. For a range, and be very similar, we're just going to look across the other way. So I can see right here, I have a 2, right? It's coming out from both sides. I have a 1 also coming out from both sides. No duplications. This one's coming in from the left. This one's coming in from the right. Wait, right then left. Okay. So the range starts off with -2. Then -1, then 1, and then 2. So it does look a little bit different when it comes to over here. Okay, so for continuous, once again, we're going to start with domain first. So this is for number 1. And then I'll draw a little arrow up here. So this is the domain. So the domain over here is going to look at the x-axis. So I have no number on the left side. You could represent it with negative infinity, but for simplification purposes, we're not going to do that. And I can see right here, I start off at a 2, okay? So 2 is on the right side of the graph, negative infinity is on the left. So that means I'm going to write 2 over here, and then x is in the middle. Because it's a closed dot, we're going to put the less than or equal than symbol. And like I said, this essentially is negative infinity. However, we want to just simplify it to that amount. So you can always write it and erase it, but for simplicity, please just put that, okay? And then for range, kind of similar, right? So we're going to go from the bottom, which is -2. It is a closed circle, so we're going to put the less than or equal than sign to y, and then it's going to go up, 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 up to infinity. So we could just leave it as is. So here's the domain, and then here's the range. Okay, so today we're going to kind of build off of that. We're going to do some more practice, and then we're going to go up from there and continue into stuff that's more real life, okay? So, I'm going to erase. It says the goal is to interpret a reasonable domain and range in the context of a real-world problem situation. The essential question is, why do we care about domain and range? Okay, so remember that the domain represents a set of all x values and then the range represents the set of all y values. I like to remember it by D becomes before R, so X comma Y, right? It's going to be D comma R. Is that anything official? No, but it helps me remember. Okay. So discrete function, we're going to list all of the X and Y values inside those fancy brackets from smallest to largest. Don't repeat values, okay? So if you have one that has it more than one time, you only need to write it one time, okay? For continuous functions, if it's an open dot, you're going to put the less than symbol. And if it's a solid dot, you have the line below, okay? Just a reminder, continuous functions are any line that continues. It does not have to look similar to other ones. Discrete is going to have dots or points. Okay, so let's begin off with a little bit of practice. So we're going to identify the domain and range from the set of ordered pairs. So let's start off with the first question of, is this continuous or discrete? Well, we can see points, so we know that this represents a discrete function. It would be dots, basically. So looking at the domain, I see a 2, a 1, a -8, and a -4. So my smallest number that I have is a -8, and then -4, and then 1, and then 2. Okay, and then for the range, let me find a different color that will stand out a little better. Okay, so for the range, we have -9, -4, -8, and -4. So the smallest number is -9, and then -8, and then -4. Remember, we have duplicating -4s. Do not repeat. Okay. Okay, so for the next one, it says to identify the domain from the scatter plot. Oh, it should say domain and range, but that's okay. I believe it says it on your paper. So first things first, we're going to determine whether or not it's continuous or discrete. So this one is a discrete function, okay? Now the domain is going to be the range of X values, okay? So domain, we have a 1, a 2, a 3, a 4, a 5, and a 6, okay? Pretty easy. So I'll just do it in that order. Now, when it comes to the range, we have a 6, a -3, a 2, a 1, a 0, right? If it's on the axis, it represents a 0, and a -1. So you want to start from the bottom, work our way up. So start off with a -1, 0, 1, 2, 3, and 6. Okay? Okay, so this one is a little bit different, right? We can see that this is a continuous function instead of a discrete function. So I'm going to go ahead and select that. And then we can take a look over here, and I can see that for the domain, we're starting off over here, so that would be at -2, and it goes over here to 4. Okay, so over here, That is a closed circle. Closed circle. So that means it's going to have the less than or equal to symbol. So we'll start over here at -2, less than or equal to, x is in the middle, less than or equal to, and we see we have a 4 here with an open circle, so we take out that line. Open circle means there is no line below. Okay, so I'm gonna put the 4 over here. And then we can do the range. So the range, the bottom side starts at -3, and then the top goes all the way to 2. So we'll start off there, -3, closed circle. And then 2 is our open circle. Okay, perfect. Okay, so let's take a look at this function. So this is another continuous function. We can see that there is no dots, there's no disconnection among that line. So the domain, we can see that this arrow is essentially saying it's going all the way this way, and it's going to continue all the way this way as well. So when it goes to infinity and negative infinity in both directions, that could be represented by all real numbers. Now the range we can see is a little bit different. We can see that there's a bottom portion, which would be the left number, right? So that bottom number would be right here at -6. So if it's the bottom number, it's going to be on the left side of the y. So -6. And even though there's no dot, there's no circle. So we can assume that it could be equal there. And then we put our y. We don't represent a number to the top because it's going towards infinity. But this would be our final answer for this one. Okay, so the next one is to graph this function. So let's start off with the domain. So with the domain, I know I'm going to be at -4. 1, 2, 3, 4. So I'm going to be out here at -4. And then I'm going to have my right side be at 5. 1, 2, 3, 4, 5. Hopefully you guys can see that on your screens. Maybe I'll do it a different color. Okay. And then the range is -2, so go down 2. 1, 2. Okay. And then I go up 6. 1, 2, 3, 4, 5, 6. Okay. So we're essentially going to find where they meet. So this goes this way. This goes this way. They meet right here at this intersection. And I can see for both of these, there's no line underneath. So that's going to represent an open circle. Okay. Okay, and then I'm gonna go over here and I can see that it'll come this way. I'm just kind of doing small dots just to help me. And it's gonna be over here. But I can see it's all the numbers less than 5 and less than 6. So that has a line below, so it's a closed circle. Okay. And then from there, all I have to do is do my best to draw a line across. So now we're going to get into the applications. So far you can see these are just graphs, dots. Before, I know we've talked about in class, like you can't have half of a puppy, right? Things like that. So now we're going to go further into the applications. So application of domain and range. Reasonable means any possible, so that is a key word, hint, 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 or makes sense, therefore only x and y values make sense in the problem or situation that are considered reasonable. Reasonable domain and range would be possible for the independent and dependent values. So independent is the x values. You don't have to write this down if you don't want to, but this would be the x values. And this would be the y values. Okay. Go ahead and make sure you have that written down. So what I have highlighted is what you need to write down. You could write in x and y values there too. That's up to you. That's personal preference. Okay, so moving on. Reasonable discrete examples. So the number of puppies in a litter, there are no fractional puppies or no partial puppies. So that would be your answer right here. No fractional puppies. Okay? And then the number of people in your class, because there's no fractional parts of a person, right? You cannot have a third of a person in class. Math does not condone murder. Okay, so these are discrete examples, okay? So think of whole numbers. Think of things you could say, oh, the number of puppies, the number of people who have glasses in the room, the number of people who are wearing jeans today, right? They're going to be whole numbers. Could also be negative whole numbers. And reasonable continuous is going to be any value, okay, keyword there, value measured within the range of horse heights. Okay, time to complete a task, it could be measured to fractions of a second. Okay, so the application of reasonable, domain, and range. So make sure you can determine if the situation is continuous or discrete. And identify which values are independent and dependent. So these are kind of older people examples. Hopefully you guys know what they are. But a light bright is where you put individual like dots in there and it creates a shape. Etch-a-sketch is where you have like a little line and then you kind of start going through and start sketching, right? And then it kind of creates like a shape or a figure. So it's just some examples to show the difference between them. Okay, so let's take a look at this next situation. It says, well, first let me start off with the instructions. It says application of reasonable domain and range. Make sure you can determine if the situation is continuous or discrete and identify which values are independent and which values are dependent. And then you could talk about the reasonable domain. Okay, so this problem says the function of 1.5x plus 8 represents the cost y in dollars of a taxi ride of x miles up to 100 miles. And then it says decide whether it's continuous or discrete. So can we have half a mile? Sure, why not? That totally works. So for this problem, it's going to be continuous, okay? So remember, we can write it in the inequality form. And this is just asking for domain, okay? So it says cost is y, okay? X is miles. So in order to find the reasonable domain, you need to look at the number of miles. You need to look at x, which is miles. Okay, so let's take a further look within the problem. So I know x is miles. I know this function, right? I don't really care about cost. It's not adding about cost, but it does say up to 100 miles. That's pretty big. So there is a possibility that of all reasonable domains. So for a reasonable domain, it's the least to greatest. And in order to think about the least, we want to think about realistically how many miles can we actually go. So even if you just hop in the taxi, they're probably going to charge you something, probably whatever this $8 is, right? Because people want their money, which is okay. And so you can't go negative miles, right? You can't do reverse miles and the driver owes you back. That's not how it works. So I would say the least amount of miles would be 0. Okay, and then we want to go to the greatest. So it does say up to 100 miles. So within the problem, we already know the biggest amount is 100. And that right there would be your answer. Okay, so this problem says the function y equals 500 minus 25x represents your gift card balance y after you visit up to 20 days x at the trampoline park. So the first thing we want to do is determine whether or not this function is continuous or discrete. So it's saying 20 days. So usually whenever you go to a park like this, they don't care if you show up for 1 hour, 6 hours, the whole day. You're usually paid for the day. Such as if you go to the zoo, right? So let's say you buy a ticket to go to the zoo. Does not matter if you spend 30 minutes there or 30 hours there. Well, that wouldn't work, but doesn't matter if you spend 3 hours, 30 minutes, 12 hours, right? They count the number of days you're there. So this would be a discrete function because they're not going to charge you half of a day. Now, for a reasonable domain, it says that the key word over here is up to 20 days for your x values. So remember, domain does cover the x values. Oop. And so we want to think about realistically how many days. So you could realistically go, least to greatest. The least amount of days you could go would be 0 days, okay? And then the most would be 20. However, this isn't like the last one. This is actually a discrete function. So we would go ahead and count the days, right? Since we can't do half days, a third of a days, you just, when you go, you count for the whole day, just like the zoo. So it's going to be something along like 0, 1, 2, 3, and you would continue on until you hit 20. And that right there would be your answer. Hopefully there's no questions. Okay, so moving on. It says you have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 feet squared. The function is A of Q equals 100 Q. It represents the area A of Q in square feet that quarts of paint cover. What is the domain and range for the function? So we want to determine the independent and dependent, okay? So I like to use the information that we can see, right? So A of Q right here is going to be our input or our independent variable. Q is for quarts. So 3 quarts of paint. A is a function of Q. So that means A is going to be the dependent or the Y values essentially. So A of Q represents the area, okay? So remember, independent is the x's, dependent is the y values. So right here, we would say the independent is Q for quarts, oops, quarts of paint. And the dependent is the area that the paint covers in square feet. Okay. So the next thing we want to determine is if it's a continuous or discrete. So when it comes to something like this, we want to think about, well, can you have partial or a whole, right? So can you use, let's say, half a can of paint? Sure. Why not? So what does that mean? That means it's going to be a continuous function. Okay? We're not murdering anybody by doing half a can of paint, so that would be continuous. Now, in regards to our reasonable domain, right? So same thing, we're going to go from least to greatest. X is going to be in the middle, least to greatest, Y is going to be in the middle. So it's important to note in this one, all of them are going to be less than or equal to, because you can have equal amounts of paint, right? You can equal 3 quarts, equal 2 quarts. It could equal 0 quarts, 0 feet, right? So the least amount of paint we could do is going to be none. We could not have negative quarts of paint. And the greatest that we're going to have, it already says 3 quarts. So you bought 3 quarts, maybe you use all 3, maybe you don't. Doesn't really matter. It could be anywhere from using all 3 to none. Maybe you get home and you're like, ew, that color's ugly, ew, right? Same thing. If you have no paint that you use, you'll have no area that you covered. Now, does it say anywhere up here how much area is going to cover? No, it doesn't. So you cry. I mean, you're going to go ahead and calculate it. So you're going to calculate the range with the domain. Okay, so, and actually you could do it for both. So you can see how it works for the 0. So if I have a of 0, that is 100 times 0, which is 0. You can see we already kind of figured out it would be 0, but let's go ahead and try it for when it's 3 quarts. So a of 3 is when the quarts is 3, so it's going to be 100 times 3, and that gives me 300. So I would just write 300 right here. So that's essentially how you get those numbers of 0 and 300, is you're going to take the domain and then find the range with it. Okay. So Jeremiah's car gets 20 miles per gallon. If the amount of gas used is a function of the number of miles driven, what is the domain and range of the function? So let's take a look. It says that first we want to figure out what's independent and what is dependent. Already up here, I can see miles per gallon. Okay, so the amount of gallons is dependent on how many miles that were driven. Okay, usually it's what we're going to be measuring, right? So the independent is miles, dependent is gallons. So, for example, if I drive 100 miles, then I use X many gallons, right? We got to figure out which one is the dependent, which one's the independent. The next question is it continuous or discrete? Well, can we drive half a mile? Sure, why not? So that's going to be a continuous function. Okay, so let's take a look. It says 20 miles per gallon, okay? What is the domain and range if it can hold up to 12 gallons? Okay, it says nothing in here about the amount of miles, so we're going to actually have to do that ourselves. So we'll start off with the range. So this right here is the max of the range. Okay? So y is going to be in the middle, so the max is going to be 12. And then the minimum is going to be 0. Now we have to figure out the domain. So we have to think about how we could turn this into some type of function. So let's take a look. We have 20 times miles is the number of gallons. Okay? Okay. So we can see that the car gets 20 miles per gallon. Okay? So per represents division. So 20 is equal to the miles divided by the gallons. Okay? So it's kind of weird since we have it on both sides, right? But what I could do is multiply G on both sides. Since we're dividing here, to undo the division would be multiplication. So gallons times 20 equals miles. And let's say you had the number of miles but wanted the number of gallons. You could divide both sides by 20 and you get gallons is equal to miles divided by 20. So either way, you could write this formula in 3 different ways. But specifically for what we're doing, this, I don't want it like that. This is the one that we're going to be using. Okay, so since miles is independent, that's what we're solving for. So the miles is going to be the number of gallons, which is 0, times 20, which is 0. And the number of miles is the most, which is 12, times 20, which 12 times 2 is 24. Add the 0, so it's 240. Okay, so that's where X value is going to range. So it's going to be 0 less than or equal to X less than or equal to 240. Okay, so let's keep going on. Hunter is shopping for pencils. He has $5 to spend and pencils cost 65 cents each. Determine a reasonable domain and range for the problem of this situation. So we have pencils and spend. Pencils and money. Okay, so pencils the number of pencils we buy is going to determine how much we spend. So that means that the independent is going to be pencils, and the dependent is going to be cost. Essentially how much money you spend. So we want to think, can you buy half a pencil? No. So that's going to be discrete because you count whole pencils. Okay? And this one just wants the range. So we have to figure out how much money they could spend. So it says he has $5 and pencils cost 65 cents each. So you could start off at, so remember, it's discrete, so we're going to be counting. Okay, so we start off at 0, and then we could buy one pencil, right, which is 65 cents. We could buy two pencils, which is $1.30, and so on. You can't go above $5. So the most we're actually going to spend is $4.55. That's with it being 65 cents each, and that there's a $5 max. Because if we went over by one more, that would be a $5.20. We'd be over budget, right? If you have cash in your pocket, you can't spend any more than what you already have. Okay, Gail is taking an Uber ride for 10 miles to the airport. She must pay a base fee of $2 plus 40 cents a mile. Determine the reasonable domain and range. So input is miles, output is cost. The amount of money she spends is dependent on how many miles she goes. So miles is something we measure, not count. You can do half a mile, that works. So that means we're going to be a continuous range. So we need to take a look at the reasonable range. So she's taking 10 miles to the airport, okay? So, 10 miles, not $10. 10 miles. Okay, so if it's 10 miles, it's going to be $2 plus 40 cents times the 10 miles. So it's going to be $2 plus this times this is 4. So the most she could spend is 6, right? We're going to assume Gail's going to go all the way, but let's say she wants to walk the last half mile, right? She essentially could. So remember the least numbers over here. So if she decides to get in and not get out, the least amount of miles she could spend is 0. And then the most amount she could spend is 6. Actually, if she went 0 miles, she still has to pay the base fee. So the base fee is 2. So she still had to spend the $2. Because even if she went 0 miles, it would be $2 plus 0.40 times 0. That's 0. So she'd at least spend $2. Okay, so let's take a look at the next one. So Hector's Service Club is raising money by wrapping presents in the mall. They make $3 per present, and they only have enough wrapping paper to wrap 1,000 presents. So the independent variable is going to be the presents. The dependent is the cost. So this is something that you count. You don't do half presents. which means it's going to be discrete. So we need a reasonable domain. So it says they only have enough to wrap 1,000 presents. So let's say nobody shows up, right? They have 0. But it says they do have, they do have enough for up to 1,000. So we could have 0. We could have 1 present, 2 presents, 3 presents, all the way up to 1,000 presents. Okay. Whew, last problem. So it says you burn approximately 135 calories for every mile you run. If the maximum amount run you can run is 10 miles, determine the following. So the independent is miles, which is something you could measure. You could have half of a mile, right? And the dependent is calories. So the more miles you run, the more calories you burn. Okay? Because you can measure in half, that is continuous. So range means the number of calories. Okay? So it says 135 calories for every mile. Okay? So if we run 0 miles, it'd be 135 times 0, which is 0 calories. Okay? Let's say we ran the most, which is 10 miles. It would be 135 times 10, which is 1,350 calories. Okay? So your homework is Delta Math, so please make sure you get that done. And if you have any questions, please send me an email.